assignment at this point is finished. We'll just do these last couple of paper-based assignments that we had. So, okay. So this is a pretty broad statement right here. It is possible to create a new power series for any function. You go back through and you can do that Maclaurin construction process, and that is not going away. That will be a thing that you do need to be good at. Sometimes, though, it's going to be easier to just take a series that you do know, like one of these 4 that we wrote on the board, and do some little minor and or major changes to it to get us to whatever the desired function and power series would be. The strategies we're going to take here would be algebra, things like multiplying by this, dividing by that, kind of those, essentially algebra being whatever you do to one side of an equation, you got to do the same thing to the other side. That would be the overarching algebra concept there. Substitution, kind of another algebraic concept. So if you replace x with something, then as long as you replace all the x's with that same something, it's allowed, right? It's an algebraically valid thing to do. And then, of course, the newer ones, the ones we practiced with a little bit last time, integration and differentiation. We'll go a little bit deeper with those. But those would be kind of the four main ideas. Man, Cameron, you missed out on our board work here. I'm sorry to say. Welcome to class. So basically we wrote these 4 known series. At the very end, last time we talked about, or I guess it wasn't at the very end, it's towards the start. We talked about the 4 series that you got to just know. And so we just took a few minutes here to talk about those and practice putting those on the board. So anyway, so here's what we're going to do. We're going to take a look at, say, an example like number 1 says, write the first 4 terms and the general term of the power series for f of x equals 1 over 1 plus x. And then it says include the interval of convergence. I think almost all of these say include the interval of convergence. We'll mostly follow those directions, but at some point, if I'm just kind of looking around and I'm like, you know what, these guys know how to find the interval of convergence and they're absolutely awesome at it, maybe we'll drop that on some of these, just so you know. We won't always do that, but we will do that for a lot of these. And so, bless you, I'm going to just throw this out here and say, I think you might be able to do this without any special direct instruction from me. And maybe I'm wrong, and if I am wrong, that's okay. But I want to give you a shot to try to throw some strategies out there, thinking of, knowing that algebra, substitution, integration, and differentiation, those are kind of the primary strategies that we're going to take with these. And so if you look around the room, I left these on the board on purpose. One of these 4 known power series and functions here kind of goes well with what we're supposed to be finding. Yes, I think that's hopefully fairly clear. If it's not, that's okay. But what I would want you to do is then try to use that one that kind of jumps out at you and think, how could I create that f of x equals 1 over 1 plus x and also the corresponding power series that goes with it? And I'm kind of throwing you to the deep end of the pool here, and I think you can swim, mostly, right? I mean, mostly you can swim, but if you can't, I'll jump in and drag you to shore, and we'll try it again. Okay, so ready to go. Let's see what you do. Let's kind of think about what you did, see if it was good. I think the idea of substitution, is good, for sure. So let me show you some thoughts and steps you'd want to take here from an assessment standpoint. I would want to see that you started off with the geometric series here. So we'd say this is 1 plus x squared plus x cubed plus ... plus x to the n. So Alyssa, let's hear your idea on what you substituted in.
I changed x to negative x.
So you plugged a negative x in for x. Now you are allowed to do that as long as you do it for all the x's, right? Okay. So let's see what that looks like over here on the left. If I substitute a negative x in for x, isn't that about what it should look like? So I've done that to the left side of the equation. I'm not allowed to do that unless I do it to all of the x's, correct? So let's see what happens here. The 1 is just a 1. There's nothing to substitute in there. And what did you do? Did you just plug a negative x in for all on that right side? Okay. So instead of a plus x, now it's minus x. And then it would be negative x in parentheses squared plus negative x in parentheses cubed plus ... plus negative x in parentheses to the n. All right. What do you guys think? Is that valid? Is that valid? I think it is, isn't it? That's totally valid. All she did is she said, you know what, wherever I see an x, I would like to put a negative x. So here's why this is not only valid, but this actually addresses the objective here. Isn't 1 minus negative x really just 1 over 1 plus x? So this is our objective. And if we clean this right side up a little bit, we end up with 1 minus x plus x squared minus x cubed plus dot plus negative 1 to the n times x to the n. That's really good. Nice job. Do you guys work on that together, or was that Alyssa? Nice work. Nice work. Okay. So I hope the wrestling around with it for a couple of minutes was valuable. Alyssa was like and Maya, like you guys were thinking through this, like was the substitution just kind of like this light bulb moment, or was there a lot of discussion? They're like, hey, let's try substitution.
Let's try it.
Okay. I like that idea. Like McKenna was like, hey, great job, you tried. Like that's another way of saying essentially, start trying something, and now maybe you can have a sense of what some of those somethings might look like. Okay, good job. So then as far as an interval of convergence, let's point out a couple of things. What's the interval of convergence for this? That's negative 1 to 1, and we'll start adding those onto these four known series as well. So that's negative 1 to 1. And so what we did is we substituted a negative x in for x. So that did not change the centering point, did it? And it shouldn't change the radius either, but it could have changed endpoint behavior, right? So let's think that through. So we know for sure that the center is 0 and the radius is 1. So then we don't know about the openness or closeness of those interval endpoints. And so I'm going to put it out here for x equals negative 1. This would be sigma, and we're dealing now with the new series, right? This is for the new series. This would be sigma from 0 from 0 to infinity. If you plug in a negative 1, you'd get negative 1 to the n, because that was already there. I'm looking at this guy right here. And if you plug in negative 1 in for x, you get negative 1 to the n. And that's kind of it. So is that going to converge or diverge? Diverge because of what? Nth term, yeah. In fact, wouldn't every single term be the same thing? Wouldn't it just be like 1 plus 1 plus 1 plus 1 plus 1 plus, etc.? Yeah, okay. So nth term test tells us what we want to know there. And then what about for x equals positive 1? Maybe this will be different. We have sigma from 0 to infinity, and it's going to be negative 1 to the n times 1 to the n. What do you guys think? Converge or diverge? So it's like the other one was not alternating. This one is definitely alternating, right?
It's going to diverge.
Why?
Because it doesn't decrease in absolute value from 0.
Yeah. Wouldn't the terms just be essentially like 1, negative 1, 1, negative 1, 1, negative 1? Yeah, so that nth term is not heading towards 0. So yeah, it diverges. Same reason, nth term test. Like so, and so I think we could go back up here and essentially just erase the question marks and say that it's an open interval on both. So you don't often have to do that, what we just did with the interval of convergence. I'm just doing that to, again, just kind of try to reinforce that process of finding those intervals of convergence. Well, this one did say, I'm just saying typically that's not like a, like an add-on. I suppose it could be, but I think sometimes like if it was, it would probably be some free response question, and like part A would be the first thing we did and part B would be the second, would be the finding the interval of convergence, something like that. Not always, but sometimes. Okay, let me just remind you of one other thing. And if you wanted to, I don't know if I don't really want to do this right now. If we wanted to, though, we could go back and we could start off with this, f of x equals 1 over 1 plus x, and we could say, what is the Maclaurin power series for that function? And you could reconstruct it from scratch, right? You could say, okay, if it's Maclaurin centered at 0, isn't the first term f of 0? And what's f of 0? Isn't it 1 over 1 plus 0? Look, there it is. Right there. Okay, and then couldn't we find f prime? And then find f double prime, and find f triple prime, and each time make the degree and the factorial go up by 1 each time. And we could reconstruct this, but don't you agree that once you get the hang of this, this is easier? I hope you will see that eventually. This can be a lot easier. Okay, first effort on that. You guys ready for effort number 2?
Let's do it.
Okay, so let's try number 2. Aha. So number 2. Same instructions exactly. Different function this time. Not that different, but somewhat different. Let's see if you guys can identify which power series and function you'd like to work with, and then figure out what you'd need to do to it to get what we want. So this one, looks like this one went a little better as far as getting going. Am I right? Okay, so did you guys pick the geometric series again? And what strategy as far as algebra, substitution, derivative, integral, what'd you pick? Substitution. So these first couple, obviously it's just sort of been a singular strategy. There are going to be other times when the strategy is going to be like multi-stepped, right? There's going to be like maybe a couple of things you got to do in order to make it work. Okay, so I agree. I think that looks really good as far as a strategy goes. So if we were going to substitute into the geometric series, what did you guys plug in for the x as a substitution?
Negative x squared.
Awesome. Thanks, McKenna. You guys are funny. Like you've gone from being silent because you don't know what to do to being silent because you think it's too easy.
It's very
Am
true.
I right? Yes.
Exactly.
That was a quick transition. Okay, so if that's what we're going to do, that's what it seems like. Am I right? You're just like, I don't even want to say because it was just so obvious. Maybe I'm wrong. Okay, so we're going to plug stuff in, plug that negative x squared in for all the x's. So the 1 is just a 1, but then for that first x, it's negative x squared. And then for the x squared, we need to plug in that negative x squared into that position. And then the next one would be negative x squared into the something cubed spot. And then plus dot 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 plus, and it would be negative x squared all to the n. Okay, is that looking like about what you had? Okay, so then this does get us what we want, 1 plus x squared. And then over here, we'll clean it up a little bit, 1 minus x squared plus x to the 4th minus x to the 6th plus dot 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 plus maybe negative 1 to the n x to the 2n. Something like that. What do y'all think? Is that okay from a substitution standpoint? You guys hanging in there okay? Any questions? Again, I'd like to reiterate, this is not the only way to get here. You could go through the full constructing of it using Maclaurin strategies. Should get you to the exact same spot. The intention here is that this is potentially faster and easier for you. Okay? McKenna, you look like maybe you have a thought, a question?
Why is it alternating? Because doesn't the square automate?
Yeah, it does. So like with this one, the minus doesn't go anywhere. And here, on this one, a negative squared ends up being a positive. But here, negative cubed is still a negative. So this term right here, negative x squared cubed, you could look at that as negative 1 times x squared cubed. So that would be negative 1 times x squared times negative 1 times x squared times negative 1 times x squared. So as you collect your x's, you get x to the 6th when you add your exponents, but then a negative 1 times itself 3 times, it still ends up being negative. And that sort of thing, we want to make sure that's down solid because that sort of thing will definitely happen. All right. We're not rushing, right? We're going at an okay pace? Okay. Cool. Let's move on now. Let's try number 3. Say again? I'm not going to do the interval of convergence. I'll just kind of do that sparingly. Okay. So I'm really interested to see what you guys do with number 3. There it is. And whatever you do with it, hopefully we'll get to a good place, but then I think there's a few interesting things to discuss about why this ends up being what it is. So check it out. Same instructions, new function. Let's check this out. We're going to start off with the geometric series because that's the one that fits. We'll do the other ones later on. I don't feel like this is the only one we do, but this one has fit so far. So you guys said you used it. What did you guys use? Integration, differentiation, algebra, substitution? It's been kind of a substitution sort of day. Yeah, it has. So what I would do is I'd start off with 1 over 1 minus x is 1 plus x squared plus x cubed plus ... plus x to the n. And I'm going to include the interval of convergence here. I'll just put it up there for now. I think we'll mess around with that a little bit at the end here. So then, if you are going to substitute, what did you guys plug in for x? 1 minus x. So algebraically, this works out pretty nicely, right? Distribute the minus sign. The ones add out. Minus the negative x is really plus x. So this would give us 1 plus 1 minus x plus 1 minus x squared plus 1 minus x cubed plus ... 1 minus x to the n, like that. And I want to pause here for just a second and talk about what's happened here. This is a little bit different from numbers 1 and 2 because with numbers 1 and 2, I told you guys, hey, you know what? You could have just done a Maclaurin construction for this, and you would have ended up with the exact same thing, right? So did you notice, of course, I'm sure you know that the original power series for geometric is Maclaurin, right, because the centering point is 0. But based on the substitution that Lenny suggested, and this is the best thing to do, the centering point is no longer 0. What is it? Can you see it? Yeah, it's like here. You can see on all these, they're no longer just x or like x minus 0. They're all 1 minus x's. Okay, so that actually means the centering point is no longer 0. Now it's 1. Let's talk real quick about why this has to be. There's no way that you can write a Maclaurin polynomial for this function. Any ideas why? Why does it have to be centered at something other than 0 for this particular function? Yeah, okay, keep going with that. She's right. Maclaurins are centered at 0 and 1 over 0 is undefined. What else is true? Think about when you do a Maclaurin, or Taylor for that matter, when you do Maclaurin, don't you find the first derivative, plug in a 0, find the second derivative, plug in a 0?
Undefined.
Aren't all of those?
Yeah.
They're all undefined, right? Going back to what McKenna said, she said 1 over 0 doesn't exist, or something along those lines. What's happening on the graph of 1 over x at 0? It's a vertical asymptote. Isn't this, I'll erase this, but isn't this the classic, that's a terrible representation, but you get the idea, right? That's the classic rotated hyperbola, yeah? And so when you think about, okay, if I'm going to center my power series at 0, what's actually happening at 0? Nothing exists for this particular graph when x equals 0. No first derivative, second, third, fourth, fifth, 10th, 20th derivative. The function doesn't even exist there to begin with. And so to center your series on a place where the graph, the function doesn't even exist, is going to give you nothing. So we've got to move the centering point. And so Lenny's idea, of course, of moving the centering point to 1 accommodates the thing that we were trying to find here. So this would be probably the most efficient way to do this for here. You could, of course, say, hey, you know what? I really don't want to center this at 1. I want to reconstruct a Taylor polynomial, center it at 9. Fine. Whatever. This, based on what was requested, I think Lenny's idea is the best idea. Makes sense? And I think you guys maybe shared it as well. So then let's finish off real quick by talking about what the interval of convergence might look like. The original interval of convergence is right here. And if you wanted to, you could take this nice nth term and run a full-on ratio test with it, find the radius of convergence, test your endpoints, so on and so forth. But here would be my proposal. Why not take the original interval of convergence, and just like we substituted in for x, do it again. So I would say my interval of convergence, I could start off with -1 is less than 1 minus x, which is less than 1. And wherever I see an x, I'm just going to continue to put a 1 minus x. This will at the very least establish kind of that provisional interval of convergence, give me my radius, and at least tell me which endpoints I need to consider. So if I subtract 1 from all sides, I get -2 is less than -x, which is less than 0. And then dividing by -1, I get 2 is greater than x, which is greater than 0. Or the more classic way of looking at it, 0 is less than x, which is less than 2. Right there. Now, as far as the endpoints, let's just do this mentally. If you try the left endpoint of 0, wouldn't you get 1 minus 0 to the n? And think about that. 1 to the n, sigma of 1 to the n, converge or diverge? Diverge, nth term test, right? And if you try the 2, you get 1 minus 2, which is -1. We're just doing this verbally because we're almost done with class. -1 to the n, converge or diverge? Diverge, it's that -1 plus 1, -1 plus 1 routine. So again, nth term test tells us that it'll diverge. And so I think we would stay with this double open interval for our interval of convergence on this one. Okay? So that's it, right? We're done? 50 after? Yeah. So tomorrow we'll pick up the pace a little bit. We did 3 of them today. I'm thinking we have a longer class. We'll probably do like 5 or 6, something like that. But be prepared when you come to class tomorrow. Let's see if we can get a couple of other folks besides the ones that tried today to go up there and see if they can get these series. I hope by now you know the geometric series better than you did at the start. Maybe the other ones will be coming along too. So hope you guys have a great day. I'm excited to get this finished up with you.